Okay, so there are two types of interest that we're going to talk about right now. The first kind is simple interest. It's interest that's calculated only on the original sum that you deposit, which we call capital, versus compound interest, where every time you calculate interest, you're going to include the whole amount in the account. So even if that means that after 3 years you've gotten, let's say, $20 in interest over the past 3 years, then they're going to calculate their next interest, including that $20. Simple interest is not actually part of the IB Math Studies curriculum anymore, so you don't have to worry about problems talking about simple interest. All you have to worry about is problems talking about compound interest. So here's our formula for compound interest. We have future value is FV, present value is PV, the number of years is N. Okay, all of those are pretty self-explanatory. The two things we have to talk about are R, that's our interest rate per year, okay, and that's going to be as a percentage. And then we need to talk about K. K is the number of compounding periods per year. So sometimes they're going to say, oh, I'll give you 2% interest over the year, every year, okay? Well, then you're getting 2% interest each year, and it's only calculating or accruing at once in every year, so your K would be 1. But sometimes they might say, I'll give you 2% interest accruing monthly. Well, if they're giving you 2% monthly, that means that they are going to accrue your interest every month, 12 times in a year, so your K would be 12. Okay, let's say they say, oh, I'll give you that 2% annual interest, but I'm going to calculate it or compound it quarterly. That means that your K would be 4 because you are going to get your interest accruing 4 times in the year. Okay, so let's go ahead and look at an example. We're going to start by writing out our formula. Oh, I did not mean to. Okay, so we are going to fill in what we know. We know that Paco starts with 12,000 pesos. We know his interest rate is 4.8%. And we know that we want to see his how much money he'll have in the bank after 5 years. The only thing that we have to make sure we still fill in is the K value. Remember that the K value represents how many times it's compounding in a year, and if it's compounding yearly, it's only compounding once per year. So from there, we're just going to enter that into our calculator, and we see that Paco will have 15,170.07 pesos. Now to check for Peta's bank balance, we are going to, again, fill in what we know. She also starts with 12,000. Her interest rate is 4.6%, also for 5 years. Now for K, for her, if it's going to compound every 3 months, in 1 year it'll compound 4 times. So we are going to enter that into our calculator. And we get that she will have 15,083.39 pesos. So the question is, which twin made the better investment? And we can see that after 5 years, Paco will have more than Peta. He'll have $86 more. So I would say that that might mean that Paco made the better investment. Okay, now looking at a similar problem, same idea applies. We're going to go ahead and just write out what we know. Oops, sorry, that's R over 100K to the Kn. So we know that Jan is starting with 950, and we want to know when he's going to have double, so that puts his future value at 1900. The interest rate is 3.8. It's compounding yearly, so K is just 1. And we don't know how long that's going to take. That's our goal, is to find out how long that's going to take. So we can start to solve this by dividing both sides by 950. And we end up with 2 is equal to 1 plus 3.8 over 100 to the n. Now this is an exponential equations problem, so if you think back to our unit, you'll want to go ahead and graph and solve for the intersection. So you'll have to play around with your window to get it to show it properly, but here it would look like this. Okay, so when we look at that graph, we can find the intersection. It says 18.5, comma 2. Now the thing is, since it's only compounding yearly, after 18.5, it's not going to have compounded again to get the double. So it won't actually have doubled until the 19th year. So it's going to actually take 19 years in order for Jan's investment to double. Go ahead and work examples 14.3 for extra practice. Okay, so on your graphing calculators, you can go ahead and do the same equation that we were just doing, but with your graphing calculator, it can do it for you. It's going to prompt you for these things right here. So the first thing it prompts you for is n, which is the number of years, okay? I is going to be your interest rate, and that is going to be written as a percent. PV is your present value, just like before. The only difference is that on your graphing calculator, when you enter your present value, you have to put in it as a negative. One of the two, either present value or future value, has to be negative. So make sure, just always go ahead and put in your present value as a negative. Your payment, PMT, you're not going to touch that, so don't change it. FV, that's your future value. Payments per year, again, we don't do payments, so you don't have to touch that, just leave it be. And then C per year, that's your compounding periods per year. So that's your K value from the equation. How many times is it compounding in your interest in year? Is it annually? That'd be 1. Is it quarterly? That'd be 4. Is it monthly? That'd be 12. Okay, so here's how you get to the financial section of your calculator. You're going to press the button that says Apps. It prompts you, it asks you if you want finance. Yes, that's what we're doing. And then you're going to choose number 1, TVM Solver. And that brings you to where you can input all these things that you know. Okay, so once you've opened the TVM Solver, from there you just have to be able to enter in the important information. So in this example, we have Marie with $680 to invest. She's going to put it in a bank that pays 3.7% interest compounded annually. And we want to know 3 things. How much money will she have after 10 years? How long will it take to double her investment? And let's say she wants her investment to double in 15 years. What's the interest rate she needs? So let's go ahead and take a look at how the TVM Solver can help us solve this. Okay, so in order to do this on your calculator, you need to figure out a couple things. So n is the number of years. So Marie is asking how much money she'll have after 10 years. So n would be 10. The interest rate, this is unique, it's as a percent, not as a decimal. So they say 3.7% interest, we enter 3.7. The present value is going to be what she has now, but we always are going to have to put it as a negative, negative 680. Okay? Payment, we're going to leave as 0. We're never going to touch that. Future value, we're going to leave for right now because that's what we're going to solve for in a minute. Payments per year, that's always going to be 1. And then compounding per year, how many times are they accruing interest each year? So they're just doing that percent, 3.7% annually, so once per year, so it would be a 1. If it was 3.7% monthly over 10 years, then compounding periods per year, C per Y, would be 12. If it was quarterly, C per Y would be 4. Okay, but it's only compounding once per year. Now, future value is what we are going to solve for. So in order to solve, we highlight what we're trying to solve, and we say alpha, and then enter, which is solve. When I hit enter, alpha enter, it gives me my solution. Okay, so 977.904. Now the next part says, how long will it take for her amount in her bank to double? So the first thing we have to do is figure out what is double of 680. So that would be 1360. So we want to know when her future value is going to be 1360. So we're now solving for the amount of time, the number of years. So I'm going to go to n, and again I'm going to press alpha, enter, alpha solve, and that tells me that it'll take 19.1 years for it to double. Okay, so 19.1 years. Now, the last question says if she wants it to double in 15 years, so n would be 15, what would the interest rate have to be? Okay, so notice I'm just filling in what we know and then solving for what we don't. We want to know what would the interest rate be. Instead of 3.7, let's say alpha, solve, and it would have to be 4.7% to double in 15 years. Okay, so here is the last part of this problem. Okay, in this example, it's asking us, what if Marie has the option, instead of doing 3.7% compounded annually, what if she has the option of doing 3.6% compounded monthly? So we're going to change that percent to 3.6, and it's over 10 years, but they're not compounding it just once a year annually. They're compounding it monthly, which means they're compounding it 12 times per year. So my C per Y has to change to 12. Now I can go to future value and say alpha solve or alpha enter, and it tells me that she would make 900, or she would have total $974.13. Okay, and so we can compare that to what we got before with 3.7 compounded once per year. That was the 3.7% compounded annually, where she made $977.90. So it would be better for her to compound it annually at 3.7%. You can rework the same problems you worked after, like in the middle of this podcast where you worked them by hand, and now you can go ahead and double check them with your graphing calculator. See me if you want some extra practice problems.